So let's just move on further and see the question number 2. The question number 2 says that find the area of a quadrilateral ABCD in which AB is 3 cm, BC is 4 cm, CD is 4 cm, DA is 5 cm and AC is 5 cm. So let's just draw the quadrilateral first and let's see that what are these sides that are given to us. So let us suppose if I'm drawing a quadrilateral over here, let us suppose this is my quadrilateral and the sides that are given to us is nothing but of the form, let us suppose it is A, B, C and D. So it says that AB is 3 cm, so this is nothing but 3 cm, BC is nothing but 4 cm, CD is 4 cm, further DA is 5 cm and there is a diagonal AC given to us which is nothing but of 5 cm measurement. So as you can see, we have this particular quadrilateral in which we have the two triangles ABC. Let us suppose if I'm talking about this one is my first triangle, this one is my second triangle. So if I'm able to find the area of this one and this one, then I can combine the area of both to get the area of a quadrilateral. So let's just see how we can find the area of the single triangle. So let us suppose if I am taking this particular triangle as the triangle number 1 and let us suppose if I'm taking it as 2. So first of all, if we are talking about the area of the very first triangle, so let's just see that in the very first triangle we have the sides as 3 cm, 4 cm and 5 cm. So this 3, 4 and 5 is actually making a Pythagorean triplet. What does it mean? If I'll use the Pythagoras theorem for this particular triangle, then the whole 3 measurements are actually satisfying the relationship, that is hypotenuse square is nothing but is equal to perpendicular square plus base square. So let's just see how. First of all, if I'm using the Pythagoras theorem, so I can say by the Pythagoras theorem, we do know that hypotenuse square is nothing but is equal to perpendicular square plus base square. So if for this particular triangle ABC, so in the triangle ABC, as you can see, AC's square is actually coming out to be equal to AB square plus of BC square. So let's just plug in all the values over here to see whether the 3 sides are satisfying this relation or not. So let us suppose if I'm substituting the value of AC over here as a 5 square, this is nothing but is equal to AB. The value of AB is actually 3, so this is 3 square plus of 4 square. So let's just add up all these values and let's see whether the left hand side is coming out to be equal to the right hand side or not. So 5 square is actually 25 and further we have 3 square which is 9, 4 square is 16 and 16 plus 9 is again 25. So it means that LHS is actually coming out to be equal to the RHS, which means this particular triangle is actually following the Pythagoras theorem. So if it is following the Pythagoras theorem, then definitely it is nothing but a right angled triangle which is right angled at B, So if this is nothing but a right angled triangle, then we can find the area of the triangle using the formula half into base into height. So let us suppose if I'm finding out the area of this triangle using that particular formula. So as you can see in the triangle ABC, as it is a right angled triangle, it implies the area is half into base into height. So let us suppose if I'm taking the area of this particular triangle as half into base into height, in which I'm taking this as nothing but the base, I'm taking this as nothing but the height. So the base is 3 and the height is nothing but 4. So let's just sort it out. 2 into 1 is 2, 2 into 2 is 4. So this is nothing but 3 into 2 is 6. So the area is coming out to be 6 centimeter square. So this is nothing but the area of the very very first triangle that we have, that is the area of the triangle ABC. So let us suppose if I'm taking it under a bracket, area of the triangle is nothing but is equal to 6 centimeter square. So let us suppose if I'm putting it under the bracket, let us suppose in a box rather than bracket, and I'm calling this as nothing but 1. So this is area of the triangle for the very first triangle, that is ABC, which was actually a right angle triangle, as we have seen using the Pythagoras theorem. Now let's just talk about the second one. So as we can see over here, we have this as 5 centimeter, this as 5 centimeter, and this is nothing but the 4 centimeter. So this is not the Pythagorean triplet, and definitely this is again not a right angle triangle. This is not a right angle triangle, but this was. So in order to find the area of this particular triangle, then we have to use the Heron's formula. So let's just use the Heron's formula to find out the area for the second triangle. So let's just talk about the second triangle. So for the second triangle, as we can see, we have the triangle having the sides as 5, 5 and 4. So let us suppose if I'm taking it as A, I'm taking this one as B, I'm taking this one as C. So ABC. So let's just talk about ABC. A is nothing but 5 centimeter, B is nothing but 4 centimeter, C is nothing but 5 centimeter. So let's just find out the semi-perimeter. Semi-perimeter is A plus B plus C divided by 2. The value of A is 5, the value of B is 4. Further we have 5, further we have 2. So this is nothing but 14 by 2, which is nothing but 7. It means the semi-perimeter is actually coming out to be is equal to 7. So let's just substitute all these values in the Heron's formula. So we can say the area of the triangle, ACD, let us suppose, by using the Heron's formula, is actually nothing but is equal to S minus A, S minus B, S minus C. So let's just plug in all the values over here of S, of A, of B and of C. So using this particular concept, let's just plug in the values. S is 7, so this is 7 minus of 5. This would be 7 minus of 4. This would be 7 minus of 5 again. So let's just see. This is nothing but square root of 7. 7 minus 5 is nothing but 2. Further we have 7 minus of 4, which is nothing but 3. And further we have 2. So as you can see, we have the values as 7 into 2 into 3 into 2. So we can take 2 common out of it, and if I'll take the 2 common out of it, then I'll get the value as 2. Square root of 7 into 3 is nothing but 21. So this is 2 root 21. So at the end, I'm getting the area of the triangle ACD as nothing but 2 root of 21. Now you can also take the approximate value of this one. You can take the value of the square root of 21, and after it you can take it as nothing but an approximate value as nothing but a 9.17 approx. 9.17 approx after substituting the value of root 21, or either you can take it as it is, that is 2 root 21. So this is nothing but the area for the second triangle. Now let's just talk about the total area. So if I'm talking about the total area, so this would be nothing but the area of the triangle first one, the area of the triangle first one plus the area of the triangle second one, the area of the triangle first one plus the area of the triangle second one. So this would be nothing but the area of the triangle for the first one is nothing but 6 centimeter square, and the second one is 9.17 centimeter square. Obviously this is centimeter square. Let us suppose if I'm writing it over here, this is centimeter square. So after writing both of these, we are getting the answer as nothing but 15.17 centimeter square, and this is nothing but the total or the area of the quadrilateral ABCD, and this is nothing but the answer which is related to this particular question, using the two type of formulas as area of the triangle as half into base into height, and the other one is nothing but the Heron's formula. So I hope all the steps related to this question is all clear to you.